All right, hello Integrated 2. We are in week 5. Tomorrow will be April 20th. Remember our scheduled time together in the block time is kind of Tuesdays and Thursdays, but I make the videos so that you can go ahead and work on them at any time. So we'll have a few parts to week 5, and so this is part 1, which is going to be an intro to the graphing the quadratics. So I'm going to make some slightly, maybe some shorter videos, and then we'll just kind of continue where I left off each time. So this will be part 1, and of course we're setting up for the week of April 20th through the 24th. Okay, we have factored quadratics, we have solved quadratics, and now we're going to graph our quadratics. Okay, so just a few reminders. Okay, I know this may be small, so if you're watching it on a small device, hopefully you can blow it up. But you can copy this down by pausing, or you can kind of just listen and decide what it is you're going to need. But I am going to be using this vocabulary as much as possible. Okay, so here we are. The quadratic equation is y equals ax squared plus bx plus c. We've been doing all our problems solving letting y equal 0, okay? So we were forcing x to come up with the solutions. Remember, 2 solutions, 1 solution, or no solution, okay? But you remember from graphing linear functions, you can make tables. You can pick a bunch of x's, plug them in, and solve for y. Well, the same thing applies here. So I can pick our x's, you can solve for y, and this is the graph that you're going to get. You're going to get the shape of a parabola, okay? And I will take you through the step-by-step process when I show you the examples, okay? And so we're going to learn that the graph of ax squared plus bx plus c, our parabola is going to go up if a is positive, and our parabola is going to go down if a is negative. One of the most important things that we'll find in any problem, or that is our number 1 thing to find in a problem, is the vertex, because that kind of tells us where the parabola starts. So you need a starting point, okay? Much like we used to find the y-intercept in linear functions. But this is more important because of the way this thing curves. So you have to find the center of your parabola. And the other thing we're going to learn that ties into this is something called the axis of symmetry. That imaginary line, just like the Earth's axis. It's an imaginary line, kind of cuts the parabola in half, so it's a vertical line, and you can see I kind of drew it in here in the red so that you can see it. Okay? So this is our goal over the next 2 weeks. This week is going to be graphing in standard form. Next week, I'm going to show you how to graph a parabola in vertex form, which actually is going to be a lot faster for us to do, and something you're going to do more and more next year when we start kind of moving these graphs around. All right. So here it is. Take down what you think you need, or come back to the video and pause. But let's go ahead and look at our first problem together. So here we are. I'm not even going to call it an example. It is our introductory problem. This is our key problem in everything we do, whether it is standard form this week or especially vertex form next week. Okay? So we call it our parent graph. And so that means basically this is where all the other graphs are going to originate from. So it's our most basic graph. If you notice and say, well, what happened to the bx and the c? Well, they're 0. And if they're 0, then there is no need for them to be used in the problem. Now, since I know a little bit about the problem, okay, I'm going to go ahead and put in our first values. Okay? If x equals 0, then 0 squared, y would be equal to 0. And this happens to be our vertex. So the first thing you're going to do in every single problem, whether it's this week or next week, is you're going to find your vertex before you can even graph. You cannot graph until you find the vertex of your problem. And then we're going to go one to the right and one to the left. And then we're going to go to 2, -2. Okay? This is how we set up every problem. Even when our vertex moves, we basically go one left, one right. It should be one left, one right. 2 left, 2 right. And this is going to give us our shape. So what we're supposed to do here is substitute in. And so if I substitute in, y equals 2 squared is 4. Y equals 1 squared is 1. Can you make your 1 this way or make it that way? Y equals -1 squared is 1. Okay? And the big thing on this one is when you put it in your calculator, you need to have parentheses. We talked about this last week. If you just put in your calculator a -1 squared, you are going to get a negative. So you need to make sure, especially when you have the negative, you protect with parentheses. So this is a 1. I think what I'm going to do, I think I'll do it that way. Yeah, just so it's on this side. I should have moved those down a little bit. And then y equals -2 squared, which is 4. So these are the points that we're going to put on our parabola. And I hope you're noticing that this value and this value are the same, and this value and this value are the same. And we're going to talk about that here in just a second. Okay? So let's go ahead and graph it. So there is 0, 0. One comma 1. And 2 comma 4 and -2 comma 4. And if we put 3 in, we'd be up to 9 and here. So you can see it expanding just like you can see it over here in the picture. So we're going to kind of just sketch the graph with the points we have. And we have just graphed our first parabola together. Okay? That is it. Okay? This is our parent graph. This is what we call our parent. And if you notice, all we're going to do over the next couple weeks is we're going to move it. We're going to move it down. We're going to flip it. We're going to make it wider. We're going to make it shrink. But basically, it's taking this and moving it all around and doing with it. So that's all we have for this piece right here. Okay? Now, that may be hard to see, but that is our axis of symmetry. And the reason why, if you kind of look at this here, symmetry means to have basically the same exact thing on the left-hand side or the right-hand side of our parabola. So our values will always be the same. So it's not like you'd actually have to plug in and do this 5 times. If you're going to plug in, you could do it 3 times, but I even have more of a shortcut for you that I'll talk about in the next example. So it's the symmetry that allows us to find our values a lot quicker. Okay? So take a look at what we have here, this first little intro. This is going to be the end of this video. So it's important for you to be familiar with the vertex, the axis of symmetry, I'm going to give you a system for A as being positive or negative. And now understand we've gone from solving to actually graphing. And along the way, I'm going to try and tie in some of the things we've been doing over the last month or so to show you that everything we've done is all related to each other right here. Okay? So let's end part 1, and I'll get ready and we'll do part 2 here in just a second. Thanks.